Hello, welcome to another episode of Science Made Easy. Today we are on chemical compounds and how to name chemical compounds to be precise. In naming chemical compounds, there are a few steps we need to follow. Step 1, it is very important we know the chemical symbols of the elements we are using to make the compounds. Step 2, in naming chemical compounds is knowing the atomic numbers of the elements. Step 3, after we have found the atomic number, we will have to figure out the electronic configuration. That is, the first shell, the K shell, takes only 2 electrons, followed by the L shell, which can take a maximum of 8 electrons, then M, which takes a maximum of 8, and N also takes a maximum of 8. Step 4 is figuring out the charges. Once you know the electronic configuration, that won't be too difficult. And finally, step 5, you exchange the valences. Let's try one example and see how we are going to go about this. Aluminium plus chlorine will form a new compound which will be called aluminium chloride. The name of the anion or the negative charge will always change from in to ide most of the times. So step 1 says we should find the names of the symbols for the elements. Aluminium has the symbol Al and chlorine has the symbol Cl. Step 2 says you get the atomic number. On the periodic table, we can know the atomic number for aluminium to be 13 and the atomic number for chlorine to be 17. Step 3 says we should find the electronic configuration. Once we know the atomic number, we need to distribute the electrons. The electronic configuration tells us how the electrons are distributed on the various shells or quantum numbers. Aluminium with atomic number 13 tells us that K shell will take 2 electrons, L shell will take the maximum 8, and M shell, which can take a maximum of 8, but there are only 3 electrons left. So we have the electronic configuration as 2, 8, 3 for aluminium here, and we have the electronic configuration for chlorine as 2, 8, 7. Now, taking the valence electron, that is the electron on the last shell. In this case, for aluminium, the last shell is the KLM. So M is the last shell. Now, if the electrons on the last shell are less than 4, as in this case, then the atom is going to lose electrons, all the electrons. And once it loses the electrons, you're going to get a positively charged ion. So aluminium, since the valence shell is less than 3, to form a stable atom, going to lose all the 3 electrons in order to get a stable atom which has 8 electrons in its last shell after the 3 has been lost. So in that case, the number of protons, which initially was 13, and the number of electrons, which was also 13, in that case there was no charge for aluminium. But now, since it has lost 3, the number of electrons are now 10. From this simple explanation, aluminium will now have a charge of plus 3. Chlorine, with the electronic configuration 2, 8, 7, and we compare the last electrons, there's the valence electrons, to the number 4. In this case, 7 is greater than 4, and that means that it will not lose all 7 electrons, rather gain 1 electron to form a negative charge. So once it gains 1 electron, it's going to have 1 more electron than the number of protons. Initially, every atom has equal number of protons and electrons. Once it loses or gains, then there is a charge. The next thing we'll do is to exchange valences, and the valence is simply the charge without the sign. In this case, chlorine with a charge of -1 will have a valency of 1. Aluminium with a charge of +3 will have a valency of 3. So we exchange the valences, and that tells us the number of atoms required in forming the molecule aluminium chloride. So we need 1 aluminium atom and 3 chlorine atoms when forming this molecule. That is the chemical symbol for the compound aluminium chloride, and each compound aluminium chloride is made up of molecules AlCl3. Example 2. Calcium plus oxygen. You're going to get calcium oxide. Once you combine them, the negatively charged atom will always change its name to ide. Step 1 says that we should get the atomic number, which is 20 for calcium and 8 for oxygen. Step 2, write the electronic configuration: 2,8,8,2 for calcium and 2,8,6 for oxygen. Step 3, figure out their charges. Now, how do you figure out the charges? By comparing the valence electron to the number 4. If it is less than 4, as in the case of calcium, then it is going to lose the electrons. Once it loses the electron, it becomes positively charged, and the charge is the number of electrons lost with a positive sign. For oxygen, we compare the valence electron to the number 4. Now, since 6 is greater than 4, since 6 is greater than 4, it means that it is going to lose the electrons. It's going to gain electrons. And gaining electrons to make the valence shell filled, we're going to gain 2 electrons to fill out the valence shell.